Good day, everybody. How are you all? Today, we are going to discuss how to find the confidence interval for standard deviation using normal approximation for chi-square distribution. So here is the problem statement. A sample of size 101 from a normal population has sample standard deviation S is equal to 40. Calculate the 95% confidence interval for population standard deviation sigma. Since the degrees of freedom is large, assume that the chi-square distribution is reasonably well approximated by a normal distribution with a mean k and variance 2k, where k is equal to degrees of freedom. So, solution. K in this case is degrees of freedom is sample size minus 1 is 101 minus 1 is equal to 100. So the mean is equal to mean of the normal distribution. Chi-square is approximated by a normal distribution with a mean of 100 and sigma square of 2 times 100, which is 200. Or sigma standard deviation is square root of 200, which is equal to, so in our calculator, we press the second button and then X square button in the first column. Inside the square root, type in 200. Because the variance is 200, square root of that is a standard deviation, and the answer is 14.14. Okay, so the situation is somewhat like this. So if I move this a little bit and create some space. So the normal distribution, chi-square distribution is approximated by a normal distribution, and that will be, I'll show it to you in a minute. So this is your bell-shaped distribution, approximately, okay? And your mean, where the peak is the highest and the base horizontal baseline is mu, is equal to 100, and the standard deviation or average deviation of the numbers in this distribution from the mean sigma is 14.14. Okay, so again, our confidence level is 0.95, which is the area in the center. This is your sea level. This is equal to 0.95. So C is equal to 0.95. Alpha, this is pronounced as alpha, is level of significance, maximum probability of rejecting 80 when it is true, is equal to 1 minus C. So alpha is equal to 1 minus 0.95 is equal to 0.05. Why do we need that information? Because area in each tail where we do not want the standard deviation to fall is alpha by 2. And this area is alpha by 2. This area is also alpha by 2. Okay, so alpha divided by 2 is 0.025. So this area is 0.025. And this area is also, area is 0.025 area. Okay, so so we need to find the critical values. These are called critical values because they separate the shaded region. So this is a critical value over here, and this is a critical value over here. Okay, so we need to find these critical values because it separates the most probable region, which is in the center confidence level of 0.95. And on the left tail, you have 0.025. On the right tail, you have 0.025. So we need to find out these critical values. So this is critical value, critical value. Which one? This one. And this one is also another critical value. So these two are the critical values of chi-square. Separate the most probable region in the most probable region where sigma will fall from the least probable region, where sigma will not fall, And these are in two tails, in two tails. So how to find the critical values on the left and on the right? Okay. Oops, sorry. So to find, we will use TI-84 to find, oops, let's change the color of the ink back to the yellow, or I may want to use a different color. Let's see if I get a nice color which will stand out in the black background. So I want a lighter color, maybe yellow. Let's try that. Okay. So to find the left critical value of chi-square, use TI-84. How do I do that? Second, then press the burst button, which is in the third row, then scroll down to number 3, which is in norm. Okay, inside in norm, area in the left tail is 0.025 and mu is 100. Sigma is 14.14. Okay, and then you paste and paste. Bring the cursor on paste and hit enter and enter. So whenever you are on paste, you have to hit the cursor twice. Do not quit right away. I will show you how to calculate the confidence interval based on these critical values. It's coming up. So let's do it quickly. So on second verse, number 3 in norm, area is 0.025, mu is 100, sigma is 14.14. I go down on paste, enter and enter. And the answer, the left critical value is equal to 72.286. How about the right critical value? Again, we will use the same function to find the right critical value. Find the right critical value of chi-square. value of chi-square. Use TI-84, but this time area to the left, the area to the left of the critical value is 0.95 in the center plus 0.025 in the left tail. So the total area is now 0.975. So again use in norm, which is second verse 3, but this time careful, area is 0.975. It is not 0.025. And mu is still remains the same. Sigma also remains the same, 14.14. And then we will do pest and pest, enter and enter. So second verse, number 3, only thing that will change is area. Why it is 0.975? Because area to the left of the right critical value, okay? Area to the left of the right critical value is 0.95 in the center plus 0.025 in the left tail, okay? And it is 0.975, 0.95 plus 0.025, okay? And we paste, enter, and enter. And the critical value, right critical value, is equal to 127.714, you might say. So these are the two critical values we will use to calculate the 95% confidence interval first for the variance, and then we'll take the square root to get the 95% confidence interval for the standard deviation. So let's move up a little bit. Okay. So 95% confidence interval for the variance will be now given by n minus 1 times s square divided by right critical value of chi square less than sigma square less than n minus 1 times s square divided by the left critical value of chi square. Remember, the critical values here are found by approximating the chi-square distribution to a normal distribution. Critical value, not values, of chi-square. Okay. So let's work on that. So remember, our right critical value is 127.714 and the other is 72.286. So this one will be, our sample size is 101 minus 1 times sample standard deviation is 40. So 40 squared divided by the right critical value, which is 127.714 less than sigma square less than 101 minus 1 times 40 square divided by the left critical value. And the left critical value is, let me make sure I'm copying the right thing, is 72.286. So this is 72.286. Okay, so we will use our calculator to do this calculation. 101 minus 1 in parentheses is 100. 100 multiplied by 40, then you have to press the x square button to square 40, and that divided by 127.714. And that gives me 1252.8, you might say, sigma square, and 100 times 40 square divided by the left critical value of 72.286, and that is 2213.43. Now, to get the 95% confidence interval for the standard deviation, we will take the square root of everything. So square root of 12, sorry, let me get rid of the, okay. To get square root of 1252.1.8, square root of sigma square, square root of 2213.43. So you press the second button, and then x square gives you the square root. Inside the square root, the left boundary is 1252.8, which is 35.39. Less than sigma square is sigma, which is the population standard deviation, and then second x square inside the square root, 2213.43. And the answer is 47.05. Okay, so how does it compare? How does it compare when we use the exact chi-square values with difference? So in the previous problem, using the exact value of chi-square, that is not approximating, using the exact critical values of chi-square in previous problem. So you must check out my presentation on the when we use the actual values of chi-square, actual critical values of exact critical values in previous problem. Using exact critical values of chi-square. The interval was 35.14 less than sigma, less than 46.43. Notice the left boundary, they're pretty close, 35.39 in one case, 35.14. The right boundary in this approximation by normal distribution is 47.05. So, and this one previously with the exact value, it is 46.43. They are not too far apart. So what is the message? The message is if the degrees of freedom is large, which in this case was 100, sample size minus 1, 101 minus 1 is 100, then chi-square distribution can be approximated by a bell-shaped normal distribution with a mean of k, where k is the degrees of freedom, in this case 100, and variance of 2k or 2 times 100, 200. Okay. In that case, if we use the approximated critical values using the normal distribution, the 95% confidence interval is fairly close enough to the actual 95% confidence interval calculating with using the exact critical values of chi-square. So this is the message. So what is the large degrees of freedom? 100 is definitely a large degree of freedom. In that case, chi-square distribution approaches a bell-shaped distribution. Okay. Normally, chi-square distribution has a skew on the right tail, is positively skewed. But when the degrees of freedom is large, it gets close to a bell-shaped distribution. I will stop here today. If you have any question or comment, write me a note. If you like this video, please give me a thumbs up. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I come back next time with another interesting math problem solved just for you. I want to make you the best in math. So please subscribe to my channel by hitting the red subscribe button. Thanks for watching. Take care. See you next time. Have a nice day.